is because they want to create lifelong learners of mathematics. And so they want the students to be able to make sense and persevere. They want them to be able to look for and make use of structure or model. These are things that you can do in science. These are also, they bridge in content areas. But that's really the heart of the standards. And then within the standards, you have these 3 instructional shifts that are different than they've ever been before these Common Core standards, which is kind of what pushes the standards forward. Obviously, there's fewer topics, right, than the previous standards. There's coherence, which means like, okay, counting and cardinality is only in kindergarten, but number and base 10 is in kindergarten, 1st grade, 2nd grade, 3rd grade, 4th. And you can see the trajectory. There's that coherence from 1st to 2nd and 2nd to 3rd. You can see how they align. But there's also more rigor. But what we forget sometimes is what rigor actually means. Well, we don't forget it. We don't know. We haven't talked about it. Rigor means these 3 things. It means conceptual understanding, procedural fluency, and application. And if you're not getting to these, you're not hitting the various DOK levels, and you're not going to have a rigorous math class. So these are really what make up rigor. So that's really what we're going to be talking about today, on how these 3 components work together. Actually, we're only going to be focusing on the first 2, but how they work together. And I like this nifty little graphic. So you have the mathematical progressions, and they get harder, but they're like stair steps. And what keeps pushing you forward is that rigor and that coherence. So every year, if the kids are getting the same level of rigor, and they're focusing on conceptual understanding, procedural skill, and fluency, then each year it's going to get easier and easier for them because the instruction is based around this. So each year they're going to be asked the same kinds of questions. Okay? So we're going to start by just jumping right in. And I'm going to model for you, just very briefly, what I would do in my class if I was doing mental math with my students. And I'm starting out with multiplication of fractions with you guys because I want you to really put your student hat on. Walk me through how you would solve this problem. So the first thing I do is anytime I do mental math, anytime I teach a math block, mental math is my introduction to my lesson. It's the, come on in, Miss Noteboom. I tried to wait for you, and then I was like, and we're going to start. Mental math is how I provide my students with an entry point to my task later on. Okay? So the importance of the mental math is, I know that, let's just say that Amy has been struggling with fractions.
That's accurate.
And we're going to be doing an application task on fractions. I'm going to preview it and kind of do a reverse facilitation cycle. Instead of an I do it, then we do it, now you do it. It's we're going to do it, and then you're going to do it as a team, and then I will assess you at the end. That's the you do. So it's kind of backwards versus I do, we do, you do. It's we. You start with the we. Okay? And you're thinking about what misconceptions are kids going to have? What do I know that they're going to struggle with when they get to the application problem? So if this was our problem, okay, so when in my class I always have students, they think about the problem and they give me a thumb up when they have an answer, and then they give me, based on how many strategies they can think of to solve it, they put that finger up. So if you can solve it or explain it in 2 different ways, you're going to go like this. Okay, if you don't know, that's fine too. Or you can make something up, because remember, you can act like a kid.
No, this isn't acting. I don't do fractions.
Okay. Okay, so the first thing I do is I just record everybody's answer. So I'm not going to judge it or anything. I'm just going to write down your answer. Okay, so Amy, what did you have?
I have nothing.
You don't know?
I don't know.
Okay.
No idea.
Don't know?
115.
Okay.
That's what I got to.
Yeah.
With the question
115.
115. Okay, so we have, which is fine. 2 people don't know. We think it's 115th. Okay. Why? Can you explain, Sarah, how you got 115th?
1 times 1 is 1. 5 times 3 is 15.
Okay, so you took this and you multiplied it times the. So is that the numerator or denominator?
Numerator.
So you multiplied 1 times 1, and that gave you 1. Okay, so you said 1 times 1 equals 1, and then what did you do?
I multiplied the denominators.
Okay, which is what?
5 times 3 equals 15.
5 times 3 equals 15. Okay? But I'm confused. Because this is this a whole number or less than a whole number?
Less.
Okay, so, but what you just told me, were those whole numbers or less than a whole number?
Whole numbers.
Okay,
So I was thinking of them as less than.
you're thinking of them as less than? Okay.